Okay, in this video, I'm gonna talk about network topology. Um, as I mentioned before, I think before the spring break started, in a class I mentioned, if you remember, that the most important resource or scarce resource in a Hadoop cluster is the network bandwidth. Okay. Because Hadoop is designed for handling very large file, so-called big data. And also it's because Hadoop using distributed computing, that means the task will be done over multiple nodes in the network. So big data plus distributed computing means there's a lot of data is going to be transmitted between the computers. That put a burden on the network traffic or network throughput, the network speed. Okay, that's why we need to talk about network topology here. Okay, what is a topology? In a network, computer network, the layout of the computers is called a topology. So multiple computers could form a star network. That means all the nodes connect to the central network device, and they don't connect to each other directly. They all connect to the central device. That's called star network, for example. Okay, it's very typical. Or it can be a ring network. That means all the computers connect to each other and form a ring. So this kind of the network structure or layout is called a network topology. Okay, why topology is important? Because the layout of your computers, how they're connected, the way it's connected, is a matter of how fast the network can transmit your data. Also depends on the is about how do we calculate the distance between computers. So let's use this figure, use it as an example. There are four racks in this example. Okay, so here we're left on R1, we call it rack 1, R2, rack 2, all the way to rack 4. Okay, what's a rack? If you've been to, we were in classroom 388 before the break. If you remember, in the front, on the left-hand side, there's a big rack, a black, look like a tower, okay? And we have the servers put on it layer by layer. That is a rack. A rack, as you see here in this figure, that computers are laid out one by one on top of each other. That typically means they are connected into they form a one local network. That means they are all they were able to see each other, okay, directly. So computer in this rack, if they want to talk to each other, which means sending data, they don't have to go over another network device. They're directly connected. Instead, if a computer in rack 1 needs to send data in computer in rack 2, in this case, then the data must be transmitted outside of the rack, which means more network control and slower transmission. Okay. With that said, a data transition between computers that in one rack, in the same rack, is going to be much faster than the data transition between computers between racks. Okay, use this figure as an example. The very top one indicated as D equals 0. That means this blue box and this orange box. These two boxes means the data transition just in one computer. There's no even because of not really. You can imagine that the blue is the data and the orange box means a map-reduce task. The map-reduce task just can directly access the data, which means they're all in one computer. So the distance is equal to 0, D equals 0, the fastest way. A little bit slower than that, the D equals 2 when the task has to access the data within the same rack. Okay, so the blue box here, but orange box in another computer, but these two computers are still in the same rack. Okay, the distance could be assigned as 2, which means it's slower than D equals 0. Okay, between racks, the D will be 4. Okay, if you look at this case, the blue box is one computer in rack 1, orange box in the computer is on one computer in rack 2. Okay, so the data transition will be between racks. So distance could be 4, which means the data transition will be slower than D equals 2. Okay. Then D equals 6 when you have to go through data center. Okay, D1, D2 here indicates different data center. What's a data center? Like if my MapReduce program is running on a computer that is located in Glass Hall, but the data was saved in a computer which is located in Cheek Hall. Okay, then the data transition needs to go through buildings, and not even between racks, but between different physical locations. Then that's the worst case. Okay, D could be equal to 6, the farthest. Okay. Why we need to understand this? Again, the reason is because we want to have application that runs that causes least data transition, least distant data transition. Okay, which means D equals 6 is not as good as D equals 4, and D equals 4 is not as good as D equals 2. The best case is D equals 0. Okay. What also matters, as explained here, is Hadoop cannot magically discover your network topology for you. You need some help, which means when you start your Hadoop cluster, Hadoop assumes all computers the distance between computers are all equal. Okay, you can identify the D equals 0, but it cannot tell what D equals 2 or D equals 4, what's the difference? Because Hadoop cannot magically discover your network topology. You have to tell Hadoop. Okay, how to tell Hadoop? You set up a configuration. Okay, go to a configuration file. Says, well, my computer in this address belongs to R1. My computer on this address belongs to R2. So tell Hadoop. Then when you have those configurations, Hadoop use those configurations to decide the distance. When Hadoop is able to tell the differences between the distance between computers, then you will try to assign, try to use the computers that have least distance. Okay. again, let me repeat this. By default, it assumes that a network is flat, single level hierarchy. That means by default, if you do not tell Hadoop the network topology you're using, then Hadoop can assume all these computers are in the same rack, flat, okay? But when you tell Hadoop, okay, these computers in R1, these computers in R2, they're all in data center 1. And these computers in R3, these computers in R4, but R3 and R4 are located in different buildings and different data center. Then Hadoop can figure out, oh, when I try to run my MapReduce task on a specific data, I try to put them as close as to the data. Okay. Okay, this is about network topology.